Hi, let's continue from the last video. So, the graph of inverse functions. The graph of inverse function. The graph of inverse function. Right. So, consider the graph y equal to f of x. Right. So, and take any point a, b on this graph y equal to f of x. Right. Then b equal to what? B equal to f of a b, equal to f of a. Right? This is the point B. And we have a f inverse b equal to, this is the graph, y equal to f inverse x. Right? And f inverse b equal to what? F inverse b equal to, what was b? B is f of a. So f inverse of f of a, which is equal to a. That is BA, when in the graph y equal to f inverse x, when we input B, then you will get a value A. So BA is a point on the graph f inverse of x. Right? So if AB is a point on the graph, then BA is a point on the f inverse of x. Similarly, if BA is a point on the graph f inverse, then AB must be on the graph of f. Right? So from this figure, you can see that this AB is a reflection of BA through y equal to x. This is y equal to x line. Right? So if you put a mirror in here on this line, then you will get the reflection of this graph will be the reflection of this graph. That is, f inverse x is a reflection of y equal to f of x. Right? So the graph f inverse is a reflection of the graph of f with respect to y equal to x and vice versa. That is, suppose we have given y equal to f inverse x, then take the reflection through y along y equal to x, then you will get that reflected line will be the graph of y equal to f of x. Right? So I think you can understand that. That is, if y equal to f of x is a curve, then take the reflection through y equal to x, then you will get f equals x. Similarly, if you look from here, y equal to f inverse x is this one. So take the reflection, you will get this graph. Right? So this is a graph of inverse function. That is a reflection of f inverse is a reflection of graph of f with respect to y equal to x and vice versa. Right? So consider a graph y equal to, consider this graph. Consider this graph. This green line is a graph of y equal to x raised to 1 by 3, and this orange line is y equal to x cube. Right? And look this graph. Then y equal to x cube, this y equal to x raised to 1 by 3 is the inverse. We have already found that. So y equal to x cube and y equal to x raised to 1 by 3. Right? So y equal to x raised to 1 by 3 is the mirror image of each other. The graphs of inverse functions are, they are mirror images of each other with respect to the line y equal to x. Consider this graph, right? Take the mirror image along y equal to x, then you will get this graph, right? So the graph is the mirror image, right? Similarly here, this is y equal to root of x minus 1, right? This is its inverse. You can find out the inverse through reflection, right? Without finding out this inverse through the uh, without finding out through any pen work, you can find out that you can find out the graph through reflection. So this is a graph of y equal to root x minus 1. Then take the reflection, then you will get this will be the graph of y equal to f inverse x, right? So next we are going to explain which functions have inverse. Which functions have inverse? Which functions have inverse? This is a question. Which type of functions have inverse? Does every function have an inverse? Well, for example, consider y equal to x squared. And the domain is minus infinity to infinity, right? This is that graph. Range equal to range, this is y coordinate only. You will get the values y equal, since it is y equal to x squared, the values from 0 to infinity. So this is a domain. This is a domain, and the range is 0 to infinity. This is the range. Right? Each value of y in the range of y is associated with exactly each value. Take this value, right? So what is the pre-image of this one? So in order to find out the pre-image, so you draw a line parallel to x-axis through this point, right? So this is the line segment, and this line will touch this graph at these points. Draw perpendicular line parallel to this y-axis, then this will touch at 2 points, right? So this is a point, this is minus root y, this is a point root y. Since this is y equal to x square, x equal to so minus root. So if this is a point, this equal to this x coordinate is x coordinate equal to, if this is a point y, then x coordinate will be, one is plus root y and other is minus root y. Which implies that you know that this f does not have an inverse. F does not have an inverse. Why? Find out that. Why? Find out the reason and message me. Right? So the question for all. That is here. This f has does not have an inverse. Why this function does not have an inverse? What is the reason for that? Explain. Right? So then you can see that since it does not have an inverse, so we can say that we consider this graph y equal to x square. If you restrict this by, if you restrict this is the same function. This is the same function, but I am taking this by from 0 to infinity. I am taking this domain is restricted to what? 0 to infinity. Domain is restricted to 0 to infinity. And this will be the graph. Then if you take this is a point y, then this will be root y. Here, corresponding to this point, there will be two exponents. Here, corresponding to one point, there is one point, root y, right? So, this function has an inverse, right? This function has an inverse. Check it out. What is the reason? Right? So, I am going to define a function, one-to-one function. One-to-one function. One-to-one function. A function with a domain D, a function with a domain D is one-to-one if no two numbers in D no two numbers in D does have the same image, have the same image. Function with a domain D is one-to-one if no two numbers in D have the same image. That is, mathematically we can written as f of x1 equal not equal to f of x2 whenever x1 not equal to x2. That is, x1 not equal to x2 implies what will happen? F of x1 not equal to f of x2. Already we can say that if f of x1 equal to f of x2, which implies x1 must be equal to x2. Right? So this is a definition for one-to-one. From this question, since y equal to x square does not have an inverse in the common definition, that is, if you take the domain minus infinity to infinity. So, but in the same case, y equal to x square, when we are restricting the domain to close to 0 infinity, then that function have an inverse. So, what will be the condition for a function have an inverse? From that thinking, we are defining this new function, one-to-one function, right? So next is the existence of one-to-one function. Existence of one-to-one function. Existence of one-to-one function. A function has an inverse. Inverse, what will be inverse? If and only if it is one-to-one. It is one-to-one. Right? So I think you understood this. So move on to next one. Some example relating to this. Example. Determine whether the function has an inverse. First question, f of x equal to x raised to 1 by 3. Secondly, f of x equal to x cube minus 3x plus 1. The solution, f of x equal to x raised to 1 by 3. You know the graph of x raised to 1 by 3. This is the graph of x raised to 1 by 3. This is x raised to 1 by 3. Right? Right? So, using the horizontal test, what is a horizontal test? Right? What is the horizontal line test? Horizontal line test means draw a horizontal line which is the line parallel to x-axis. If it touches at one point on the graph, then we say that it is 1 to 1. This is a horizontal line test. Draw the horizontal line here and it touches only one point on the graph. Right? At each point, when we draw a horizontal line at each point on the y-axis, that line will touch at one and only one point on this graph. So, we are saying that through the horizontal line test, we can say that x raised to 1 by 3 is, this is, first one is 1 to 1. 1 to 1. First one is 1 to 1. So, it has an inverse. Right? So, what will be the case of f of x equal to x cube minus 3x plus 1? Second one, f of x equal to x cube minus 3x plus 1. Draw the graph using the graphing method, right? So when you draw the graphing method, the graph will be this type. Right? When we draw a horizontal line through any point on the y-axis, then it will touch more than one point. Right? The horizontal line passes through more than one point on the graph. Then we say that more than one point on the graph, and then we say that f is not 1 to 1. 1 to 1. This graph is not 1 to 1. So we can say that this does not have an inverse. Does not have an inverse. Right? Okay, is it clear? We have done this question very clearly, I think. Determine whether the function has an inverse, x raised to 1 by 3, x cube minus 3x plus 1. So first one we know from the graph itself, but through the horizontal line test we can determine that it is 1 to 1. The same case, x cube minus 3x plus 1, through the horizontal line test we can see that it is not 1 to 1. So the graphing is a little bit difficult. So you have to draw using the graphing method.